Okay, welcome back. For this video and the next one, we're going to be talking constant velocity. We talked what the difference was between speed and velocity in a previous video, but velocity is our displacement divided by time. It's our position change, is what we're talking about with displacement, divided by how long it takes to do that position change. So what we've done today is we've set up a 25-meter track, and we're going to be walking some different velocities and seeing what that looks like on a graph. I have my assistants Drew and Callie behind the camera again today. It's going to be spectacular. So looking at our track, you can see that every 5 meters is marked. What we'll do as we walk is when we cross one of those lines, we'll tap a button on our phone and it will record our lap time. When we have all the lap times, we'll put those in a chart and then we'll graph them. Drew's going first, and as you can see, she's going to be ticking off a button on her phone every time she crosses a 5-meter mark and records that time. Okay, I'm next. As you can see, I'm walking just a little bit faster than Drew was, also recording my times. So looking just at the data, you can see that Drew's times are there in red, and my times are there in green, and her times are about 4 seconds for every 5 meters, just about. My times are about 3 seconds for every 5 meters, so I'm walking just a little bit faster than she is. One thing to notice is that we were trying to walk very consistently, not speeding up, not slowing down, but walking at one pace the entire time. Now, if we wanted to, we could figure out what our velocities were in meters per second. We would take the meter number and divide it by the second number for any one of those data points. So it might be worth it to do 25 meters divided by each time it took to finish the whole thing. And that would give us our velocity, as long as we added a direction and said that we were traveling at so many meters per second south, which is the way we were walking down the road. Now, if you were to actually do that, you'd find out that Drew was walking at about 1.3 meters per second, while I was walking at about 1.7 meters per second. Now let's see what that looks like on a graph. So the graph that we made here is called a position time graph. It has time along the x-axis in seconds and position in meters along the y-axis. What this allows us to do is to see how position changes as time goes along. Now you'll notice 2 lines here. The red line is Drew's line, and the green line is my line. Now, one thing to keep in mind about this graph is our times were not exactly accurate as far as consistency. So our lines don't look like they're exactly straight, but I think if we were a little bit more consistent with how we walked, if we walked at exactly the same pace, we'd probably end up with straight lines. Now, when looking at the data graphed for Drew and myself, you'll see that there's some similarities and differences, but hopefully it also sparks some questions that you have. For example, what would a slower person walking at a constant rate look like? Where would you draw their line? Or what happens if we walked the track backwards? Where would our line look different? Or maybe what if we paused somewhere in the middle of that walk? Now we'll try to answer some of these questions in a future lesson. But what I want you to take away from this is that the faster walker is represented by the green line, and the slower walker was represented by the red line. Thanks for watching, and don't forget to check Google Classroom for the rest of your assignment.